Hello guys, in this video I'm going to show you how to solve knapsack problem. So given the weights and profits of an item, we are asked to put this item in the knapsack, which has capacity of C. The goal is to get the maximum profit out of the items in the knapsack. Each item can only be selected once. We don't have multiple quantities of any items. So for example, we have 4 items, right? Let's say A, B, C, D. We have a list of weights and a list of profits corresponding to each item, right? So for example, A item has weight of 2 and profits of 4, right? So the item has most profit is D, which has 7. So our problem is to maximize the profit, but also we have to satisfy the capacity of the knapsack, right? Which in this case 5. So for this problem, in this video I'm going to show you the most simple way thing, which is brute force. When try to come up with a solution that try all the possible cases and combine them to find the best solution. So let's say our example, right? This one, the most profit one. The knapsack is capacity is 5. So I think this guy, the most profits, the best combinations is A and B. I think the best combination is A and B, and the total profit is 9. And the total weight is 5, which is exactly the capacity, right? If we take the most profits one, which is D, but let's say no, it should probably the C and D, because here we can have 10 profit out of these two, which is the best thing we can have here. I think 5, no, yeah, of course. So C and D is the solutions. Total capacity is 5, total profit is 10, right? But how to solve this problem? The idea is to realize that when considering every items, we have 2 choices, which is either take it or either skip it. So for example, we start with the first element, which is A. There's only 2 choices, which is take A or we skip A. right? And by realize that we have choices at every element, we can limit down our space, right? So at each step we can take it or skip it, right? So the problem now is if we take A, what is our new problem? Our new problem is find the best find the best combinations that generate the most profit out of the remaining elements, which is B, C, D, right? And also the capacity now is only the original capacity minus A, because we already count on A on the first set on the first item, right? So as you can see here, the visualization of choices at each step. So we have total of 4 steps, right? So at the first step, there are 2 choices: either take A or either skip A, right? So if we take A, there are 2 more choices, which is we take B or we skip B. The same here. If we skip A, there's also 2 choices: take B and skip B. So the same apply for C and D. So here we are trying to leverage all the possible cases here, right? So if we go this way, it means we take A, we take B, we take C, and take D. There's a multiple there are other ways as well. For example, in these directions, we take A, we take B, we skip C, and we skip D. You see, 0. Yeah. Oops. Sorry, it should be. This must be. Okay. So the main idea is to realize that we have to recognize the pattern at each step. So I think let's code it down to in order to solve this this kind of brute force. In order to try all the possible cases, we probably want to use a recursion, right? So in order to use recursions, we need to have base case, where when the recursion start, right? Base case. And the second thing is recursive call. So what are the base case here? So the base case here is when either we are but before that, let's try to determine what kind of informations we need to pass. We need to pass down for each recursive call what kind of informations for each sub-problem, right? So the original problem is find the max profit, right? Using these items, and we need the capacity. We need the capacity. Originally is 5, right? And what else do we need? Capacity. We need the profit? Or we need the items, the index of items in this guy. Probably we want to remember what are the items we are considering. Right? For example, initially it's the first item here. We're considering the first item, either take it or skip it, right? So we probably want to store the current index of current item, current index, right? So if we done with this first item, in the next recursive call, we probably want to consider the next item. So probably we want to current index. Originally 0, right? So the base case here is when our current index is out of range, which is equal to total of items index, right? The index, current index. If current index is, I think it's kind of hard to. Let's do the base case later. Let tackle the main part. I think. As we discussed earlier, at each level, at each step, we have two choices, right? At each step, we have two choices, which is skip it and take it, right? we need to find the max profit if I take it, and also the max profit. Let's say let's max profit if skip it. So in this guy, what is the max profit if I can generate if I decide to take a IE? So it's again okay. For the first case, what is the max profit if I take it? It is the max profit. It is our original problem, but we must update the capacity minus what? Minus current element weight of current index, right? And the max profit if I take it is the profit of current element, which is profit current index, and the max profit I can get for the remaining elements. So we delegate our problem down, right? So we make a choice and we delegate our problem down. So the new problem is, what is the max profit we can get with the new capacities, which is not including the previous, the current, which is current, not include the current items weight, right? And index here is a current is index +1 because we only want to consider all the elements down the trees, right? For example, we are here, we consider A, we decide to take A, so because for each item can be only selected one, so we take A, it means our space, selection space come down to BCD, right? So we increase current index by 1 to limit our space. The other problem is profit. If we skip it, it means I don't want to include profit of current element. So our problem here is the max profit. The capacity is the same because I don't take the current element, so the capacity remains, and we skip the current element, so we want to consider others remaining element, which is current index 1 plus 1. So one thing to notice here is that we probably don't want to take an element if it weights is greater than our current capacity, right? So we want to check if probably we want to initialize the max profit as 0, and only the current weight, current index, right? Only if our capacity now is greater than or equal to the item that we're about to take, right? In that case, we want to take it and to get the max profit. If we take the item, right? Why is it? Yes, I never. Okay, so we have two choices here. So down here we want to return whichever is better. So I will take the max of these two. If take it, then max profit. If skip it. So what left is the base case. The base case is when we are out of element, or the capacity is we are out of capacity. So if the current index equal to profits dot length, the total of elements, right? It means we're out of element, or we're out of capacities is when capacity is less than or equal to 0. In this case, we want to return 0. The max profit we can make when either issues is 0, out of items, out of capacity. Otherwise, we want to go and make a choice, either take the items or skip the items. If we take it, in both these cases, we limit our space down and try to solve the new problem with a smaller space using recursive call, right? So let's run the test. Okay, it works, but I don't think that I give you guys a good explanation for this video. Probably I'm gonna re-record it again in the future. So thanks for watching. See you in the next video.